Guys, this is a 2008 Nissan Altima. It has a P0455 large Evap leak. I got my smoke machine hooked up and right here, and I think I found it. I got my vent valve shut off with my scan tool right there. Okay, and let's see what I got. See some smoke coming. The camera can pick it up, but I'll get closer. Alright, let's see if I can get it. Right there. There's my charcoal canister right there, and there's my large leak right there. There you go. Alright. Well, we found a leak on our hose next to charcoal canister, and I will attempt to fix that with the JB valve. The girl that drives this car, she's a student, she can't afford, you know, changing the, dropping the tank down and getting the new hose and all that. That being a plastic hose, I'm hoping that I can put some JB valve on top of it and seal those holes. So the other two things I want to check is a purge valve and a vent valve. The vent valve I already addressed last night. What I did, once I start pushing the smoke in the system, I did not shut off the vent valve with my scan tool. I let the smoke come out. So once I located my vent hose, I observed this, you know, smoke escaping through that hose, and I used my tool to activate the vent valve. I could hear the vent valve clicking, and the smoke stopped from my vent hose, so I know my vent valve is sealing okay. The last thing I want to do is check my purge valve. I'm going to do a little bit different. With the purge valve, you know, you want to check the, you know, I'm going to use my scan tool, bidirectional control. I'm going to open up the valve and close it and see if the valve is responding. What I'm going to use, I got my end clamp on my on my control wire. This is a power size switch. It has a constant ground, and the computer applies the power to my purge valve. And other thing I did, I disconnected my, I'll show you guys what I've done here. This test will be a lot better on a picoscope. Unfortunately, my picoscope is gone. Started acting up last night, and it's dead. I know what the deal is. It's no longer functioning correctly. It's not reading voltage correctly. So, but anyway, here's my my purge valve, my hose. I disconnected it. My hose from the purge valve to the vent system. I disconnected it and adapted my 100 psi pressure transducer. And here's my end clamp. I got it over my control wire right there. And this is kind of, I didn't want to use voltage because I didn't want to pierce this connector. It's kind of goofy looking connector. It was easier for me just to put the end clamp. And on here I have my wires. So the yellow channel is going to be my current. The green channel is going to be vacuum. So this system is a half a volt, is 0 psi. So as we apply, so I'm going to use my scan tool, auto, to activate my purge valve. And once we do that, once we start applying, once the current starts going through my valve, we'll see that we'll see drop in a pressure on our green channel from our, basically it's going to be our purge valve. So let me get my bowl freezing. So honestly, you don't really have to do this. I mean, what you can just you know, put the finger on and activate the purge valve and see if it's you know, if you have a vacuum on your hose or not. But it's kind of nice to have a pressure transducer, and with my picoscope, I could customize my channel. I could measure my my vacuum. Unfortunately, my picoscope is not working, so I'll just have to use my varier. So anyway, we see there's a half a volt. It's the 0 psi. Now I'm going to increase. I'm going to increase my. I'm just going to see this. So I'm going to start. This is a duty cycle controlled valve, so we're gonna activate our purge valve now with the scan tool. So I'm just gonna start increasing the. There we go. This is a 10%, 20, 30, 40. We can see it's already. We can see the duty cycle taking place here. I'm in a vacuum. Now I'm already at 100%. You can see the engine is stumbling a little bit. We can see that it's almost dead. I need to decrease it now. So we could see that I have a control from the computer. I have a current going. The maximum is like a half a volt. Now we can see that I'm going to actually turn it off all the way. So there's no more. Now it's, you can see now my current is 0, but I'm still drawing some. I'm still in a negative pressure, and that is because I have some vacuum basically trapped in my hose. So I'm just gonna see what happens here now. I'm still having a vacuum actually behind my purge valve. I'm just gonna release the vacuum. And we can see that our pressure is back down to 0. So I'm going to do it one more time and see how. It's kind of nice to have a pressure transducer. So I'm going to. You can see it responds right away as soon as I start activating my solenoid. We can see that solenoid is opening, and this functions fine. So. Okay, so I will now. I'm going to try to repair that and see if you know, if I can seal that hole. So, as we can see now, we have a. This is our duty controlled, and right here. It's like a half an amp. It's yeah, 0.47, half an amp. So basically, it's like a 20, around 20 ohms of resistance in our purge solenoid. That's fine. So my solenoid is working fine. So, but I just want to show you guys how, you know, other way of testing it. It's kind of neat to have a pressure transducer. And okay, so this is it. I'm going to try to fix it. Hopefully I'm gonna turn my check engine light. You know, I'm gonna clean up my my trouble code and see if he's gonna pass my my test. I have a JB weld, and we'll see if I can help this girl and fix that, at least temporarily. So and I'll show you guys a shot after I've done. Basically I'm just going to mix it and apply some, you know, JB weld on top of my hose that has a tear in it, and hopefully we'll be fine. Okay, enough talking. Let me get it finished, and we'll do the final shot here. Alright guys, I'm going to show you the that little defect that I have on that hose. I got my mirror right on top of it. The camera to zoom in, and that's right there. So my plan is just to get the JB weld and fill that gap, and I think it'll be fine. Alright. Alright, well, I did the best I could. Here's the defect. Let me see if the camera can zoom that in. Probably not. But this was the defect, and I put some JB weld on it, and I think it should be alright. Well, time will tell. I'm not gonna do another smoke test. I'm just gonna let it cure for a couple of days, and I think this will work. Okay guys, before I finish this video, I want to briefly explain my method of testing the purge solenoid. So I have this little diagram. So we have here, we've got intake manifold, we have a solenoid, and then we have a fuel tank, and in between, of course, we have a trial canister. So what I did, I disconnect my evap line, and I adapted my, I connected my pressure transducer. Now, instead of pressure transducer, you can use a vacuum gauge. So when I, the first what I was looking for, and this can actually be applied for EGR, solenoid testing, or secondary injection system testing, and basically any system that is vacuum controlled. So what I like to do, I like to put my gauge in between solenoid and component that's supposed to receive a vacuum. Okay, so I disconnected the line, adapted my gauge here. So once we start the engine, the engine is going to start producing the vacuum. So we're going to have a vacuum in our intake manifold, and then vacuum is going to be applied to our solenoid. At that point, when I'm looking at my gauge, and I want to see a 0 inches of vacuum. I don't want to see any vacuum at all. If I see, that tells me that my vacuum, that my solenoid is sealed. So there is no vacuum coming from my intake through my solenoid. Okay, now if I see any vacuum on my gauge at this point, okay, the two things can happen. That tells me that my solenoid is open. Okay, it's stuck open. It can be stuck open from two reasons. It can be physically stuck open. There's a pintle inside. It's stuck mechanically, and also it can be the problem with my circuit. My circuit can be shorted out, and the solenoid can be energized when it does not needs to be energized. So to address that problem, I would simply disconnect my connector from my solenoid. Okay, when I disconnect my connector, if my vacuum goes down to 0, then I have a circuit problem. Okay, I have to investigate what's going on in my circuit. If I disconnect my connector and my gauge still reads, I don't know, 5, 6, or 10 inches of vacuum, then my solenoid is stuck open mechanically, and I have to replace the solenoid. Okay. Now the next one will be to, of course, energize our solenoid through my scan tool. Okay, so I'm energizing the solenoid. As you can see, I had my M clamp here connected. I'm sorry, it's just so I was looking at the amperage. I'm sorry, this is bad writing. So anyway, so if once I energize my solenoid, if my gauge shows 0 at that point, then there's a couple things that could happen. I can have my solenoid, bad solenoid basically, the stuck closed. I can have a problem in my circuit where computer maybe is not working, or I don't get it. At this time, this was a power side switched. Maybe computer is not energizing the solenoid, or I'm having a problem on the ground side, or having a problem with the connector itself, or I have to investigate that part. And other thing, it could be that my supply line, my intake supply line here is pinched, or maybe having a hole somewhere. So my intake is compromised. My intake supply is compromised. So basically, we are having a solenoid open, but there is no vacuum coming to my solenoid. So before we condemn that solenoid, we have to check to make sure that we have a sufficient vacuum at our solenoid as well from our supply line, from our intake. And then if we have a good vacuum, and then we check in the power and ground, and if you see the good power and ground at the solenoid, no problem with the computer, no problem with the ground, the circuit is working fine, then we have a bad solenoid. So that's the reason why I like to have a gauge behind the solenoid. So with this method, I can actually address pretty much everything that can be wrong with this solenoid. So and I can give you the shot of my voltmeter. We could see that on our graphic multimeter, and as soon as we energized our solenoid through my scan tool, we could see a drop in my vacuum, and you know, it worked fine. So that was kind of nice to see just the response of the solenoid itself. As soon as the current is applied to a solenoid, the voltage, I mean the pressure dropped down. This would be a lot better if I would have my picoscope. I could actually measure the my vacuum as well, but it is what it is. My picoscope is gone. So okay, guys, this is all I wanted to show you. I'm hoping my repair will fix the problem. We'll see probably in a week or so. I'll rescan the card and see if the Evap monitoring is done or not. I'm hoping this will be, because I'm confident it will be fine. Alright guys, thank you so much for watching, and see you next time. Thank you, bye.